What's up, chumps? Welcome back to part 2. Okay, so we're first going to talk about variables and variable assignment. Then we'll talk about data types. And then we'll end with implementing some rudimentary logic. Oh my, all right, come on, get in. Getting closer. We're talking about variable assignment. Come on, you need to be close for this. Okay. So you've probably heard of variables referenced within mathematics, specifically algebra. So we're going to start there, but don't worry. You don't need to be great at math. But anyways, let's talk about variables. Come on, what is a variable? We'll use the reference of our algorithm that we made last time. An algorithm, like we talked about last time, is a sequential series of steps that has to be completed in that order, which solves a problem. The algorithm we made last time was just a very simple one-step algorithm that adds 7 to x. So starting here, we see that x is our variable. But if we were to run this algorithm, it doesn't actually solve or do anything because x is undefined. It doesn't have a value. We haven't given it or said what x is. So in our input, we would say something like, hey, x equals 3. So when we run this algorithm, it will come over here and say, oh, add 7 to x. What's x? Right, x is 3. And now our output will give us 10. And what's beautiful about algorithms is that given this same input, we should expect that the output is the exact same every single time. That right there is the foundation of what we are building upon within computer science. Given an input, we are expecting a deterministic output, meaning that the output is going to be the exact same every single time given the same input. That's not to say that there aren't non-deterministic algorithms that exist. There are, but what we want within computer science are deterministic functions. So let's head on over to our program, opening up VS Code and opening up the main.cpp file that we ended with last video. Just our simple hello world program. Let's start with creating a variable. We're going to name a variable x. So we are going to say int x, and that's it. Sorry, I'm writing them. Also, anytime you see a little dot up here and then it goes away, it's because I've clicked Control S. In programming, you want to save. Control S just means you're saving the file. You want to save is okay, maybe that's just a me thing. I'm spamming Control S constantly. So whenever you see the little dot here go away, it means I've saved the file. But let's continue. Here is our first variable on line 4 that we are defining. So this says int x. Int stands for integer. What is an integer? It is a whole number. So it is 0, 1, 2, 3, 4, -1, -5, -8,000, right? So long as it doesn't have a decimal number or a fraction, it is an integer. What this is saying is we are telling our program that our variable x is going to be of a type integer. Our x variable is going to be an integer. So this line right here is declaring the variable x. We are telling our program, hey, Mr. Program, I want you to remember x. That x is going to be used somewhere in my program. Maybe, maybe not. But I want you to remember that x at least exists. So we can actually come over to here and we'll create a little cloud. How about that? Look at that. We're artists. This is our computer's brain. This is their brain. And we're saying, hey, Mr. Computer, we're gonna have an integer named x, and I need you to remember that. I need you to be ready for that because I'm probably going to be using it somewhere in my code. So computer-san says, okay, I could do that, and it saves x into its brain, its memory. We tell it, hey, Mr. Computer Science, please save and remember what x is, or that it even exists. And now what we can do is we can assign a value to x. We can say x is going to be equal to 3. And we're going to save that file. Also, I don't think I actually touched on this last time. In C++ and in a lot of programming languages, we end every single line with a semicolon. It's very imperative. We'll talk a little bit more into it and go in depth into it. But for right now, at the end of every line, you can see we put a semicolon. So anyways, going back to this, we are declaring a variable x, and we are setting its value to 3. So we say, Mr. Computer Science, remember x is going to be equal 3. So whenever you see x in our program, Mr. Computer Science, we want you to think of it as its value, which is 3. So coming back over here, we can get rid of hello world, and we can print out to our standard output the variable x. So if we were to run this program, what would we expect to see? We would expect to see 3. Does that make sense? Because we told Computer Science, whenever you see x, we want you to think of the value. And Computer Science has gotten in their memory, oh, right, x equals 3, x equals 3. Whenever I see x, I'm going to think of the value 3 for now. So that's what it does. However, we can also change and mutate. Mutate means change the value of x. We can say, actually, I don't want x to be 3 anymore. I want x to be 10. So when we write this line, right, we're ending in the semicolon, we're saying x equals 10. And so this is signifying to Computer Science, oh, actually, I have to go back in here and I have to change the value. So Computer Science goes in and says, hey, I need to get rid of that. It's no longer x. I mean, x no longer equals 3. They just changed it to 10, so I'm going to remember that x equals 10 now. So if we come back over here, what would we expect to see in our output? We'd expect to see 10, because Computer Science is smart. Computer Science remembers, because we told Computer Science to. However, I'm sure you've noticed something. Why didn't I write int here in front of this x? Why didn't I do int x equals 10? This is because we are declaring our variable up here. You only ever declare a variable within a scope. We'll talk about scopes later. It doesn't matter. You only ever declare a variable once. Once it's declared, you no longer have to write the type that variable is supposed to be. We no longer have to write int x equals 10. We can just say x equals 10. The reason for this is if we were to try and save this program and run it, we get our first error. And I want to take a moment to talk about this. In computer science and in programming, do not be afraid of errors. We want to seek out errors. Errors help us improve our code and make it more battle tested. It's not something of, oh, I'm a bad programmer or I'm a bad engineer. Errors help you develop bulletproof software. This is all an error is. I think it's a pretty bad name. It's more of a helper. It's letting you know, hey, there's something wrong with this program, and I want to let you know. Computer science is nice. Computer science is on our side. So anyways, let's look into this error. We can see in our output, we were given an error. It says in function main, right here, there's an error, redeclaration of int x. And it even gives us the line number that it happened on. The line numbers are on your side right here. It says at line 6, there is an error of a redeclaration of int x. And what's beautiful about C++ is this very robust error system. It lets us know everything that's going on. So if we go down, it gives us even more details. Thank you, computer science. It says, note, int x was previously declared here on line 4, int x equals 3. All this is saying is letting us know, hey, remember, you cannot redeclare a variable once it's been declared in scope. If you want to change the value, you can do that, but you do not redeclare it. So you can also see this little red squiggly line under X. If you hover over this, it will give us the exact same error that it's letting us know down here, thanks to the C++ extension that we installed last video. So we'll get rid of this, we'll save the program again, we'll clear the output down here, oopsies, clear the output, which just gets rid of the logs within our terminal, and we can run it again. And there we go, we're back to 10, we're working. Great. So now we have our first data type, integers. But what about when we wanted fractions or numbers with decimal places? Well, let's try and do that right now. We'll say x equals 3.14, and we'll save it and we'll try and run it. What would we expect to see? Up here, we're saying that x is an integer, and we know that integers are whole numbers. 0, 1, 2, 3, 4, 5, -5, -10,000, right? Whole numbers. So if we were to run this program, what would happen? Would we expect an error? No error. Huh, that's a little bit weird. But where's the 0.14? What this is saying is x, the variable is smart enough to understand that, oh, I'm supposed to be an integer. Even though I was told that I'm equal to 3.14, I know that at my heart, I am an integer. So whenever I get printed out or whenever I'm used as a value, I'm going to truncate. I'm going to get rid of the decimal places. But what if those, I hope that made sense. If that didn't make sense, I can go a lot more into detail. But all this is saying is that all that's happening here is that x understands it's supposed to be an integer. And because it's an integer, it'll act like an integer, meaning it will not hold any decimal places, even if you assign it.
If I can't have my shoes, Karen can't have her mom.
But what if those decimal places were very important to our program? What if we needed those decimal places? Well, introducing our second data type, doubles. So with doubles, you use them for anything that is a fraction, a floating point number, a decimal spot. Whenever I say floating point number, you can just think something with decimals or a fraction. They're all more or less synonymous. And this is a bit of a side tangent. Floating point numbers can go very in depth, and we will get into very deep talks about that. However, that's out of scope for this video. So when we run this program, after I clear the output, once we run this program again, we will output the full number because it knows it's a double, which means that it allows floating points, it allows decimal points, and it can print out the entire number. Great. Well, what if I just wanted 3? Can I do that? What will it print out when I run this? Just 3. Doubles can do integers as well. All integers are fractions, but not all fractions are integers. Good, cool. So now we have integers, which are whole numbers, 0, 1, 2, 3, 4, 5, -8, -5,000. We have doubles, which hold decimal places and fractions and floating point numbers, 3.1415. And now we will introduce our third data type, which is going to be the Boolean. Yeah. I'm sorry. Boolean. Well, when we write a Boolean, we just write bool. So for Booleans, we just write out bool, and we're going to name this Boolean variable x. And Booleans are either one of two things. And so the best way that I'm going to describe Booleans is think of a light bulb. That light bulb in your house can only ever be in one of two states. It can either be on or it can be off. There is no in between. If there's a light emitting from that light bulb, it's on. If it isn't, if there's no light emitting, it's off. It's the same thing with Booleans. Booleans are either true or they are false. That is the only two values they can ever be. So let's actually go and print out our variable z. As you can see, we've got multiple variables defined now. We have x, y, and z. So bool z equals true. Remember, this is ComputerSon though, and ComputerSon is smart. When we run this program, what would we expect to see? Well, what would be the easiest way for a computer to delineate, to understand the difference between true and false? It outputs 1 for true. Huh. So if true is 1, then false must be 0. Nice, nice. Exactly, right. That's simple binary. It's either 0 or it's 1. It's either on or it's off. It's either true or false. Nice. You're literally killing it. You're killing it. So those are our 3 data types that I'm going to stick with this video. I don't want to go any further because we've already talked about variables and variable assignment, data types, and now let's implement some rudimentary logic into our Hello World program. So let's come back over here and let's get rid of this. We are going to first implement the algorithm that we made over here. There we go. Where all we do is add 7 to x. So let's do that. Let's come back over to our main.cpp, and we are going to initialize or declare our variable x. We are going to say int x, and we're actually not going to give x a value just yet. But now we're going to create a second variable, which will be int result. We're not going to give that a value either just yet. So right now, if we come back over to ComputerSon's memory, get rid of that, we are telling ComputerSon to remember 2 variables that we have declared. We have declared x, and we have declared result, the name of the 2 variables. We haven't given these variables a value yet. However, in C++, when we declare a variable without a value as an integer, and we run this, so when you declare a variable but don't provide a value for that variable, ComputerSon does the following. So at the beginning of our program, we tell ComputerSon, please remember that we are declaring the variable with the name x. Please remember that, ComputerSon. So ComputerSon comes over and says, oh, I have to remember that. I have to remember x. So we put in x. But we don't provide x a value. So internally in C++, it knows its type. It's saying, oh, I'm an integer, but I wasn't giving a value. So instead, I'm going to default to the value of 0. And then it comes down here and it says, okay, ComputerSon, we are declaring another variable named result, but we aren't giving it a value. So ComputerSon comes over here and says, okay, that's fine, that's whatever. I'll add and I'll remember the variable result with the value 0. So if we were to run this program, we're going to get the value 0. Kick ass, kick ass. So this is where we get to have a lot of fun. We're going to start up here. We're going to say int x equals 3. So when ComputerSon reads this line, it knows, oh, wait a second. They have declared a variable this time, and I'm equal to 3. And if we go back to our algorithm, we are adding 7 to x. So back to our program, we have int result, and we are going to set a value for result. We are going to say result equals 7 plus x. So what does ComputerSon do in ComputerSon's brain, in ComputerSon's memory? It says result is x plus 7. Easy enough. So when it finally gets to this line, it will say, wait a second, I have a variable here. Do I remember a variable? Do I have a variable with the name x in my memory? It goes to its memory and says, oh, I do. What is x assigned to? What is the value of x? Oh, 3. And ComputerSon recognizes this x to be a value of 3. So if we are to run this program and print out result, we should see 7 plus x, and we know x is equal to 3 up here. So let's run it. And we get 10.
Captain!
Yeah?
No!
I understand it's a super simple example, but I'm positive you can see the implications of what this means. Let's go further. We can say that x is going to be equal to 8,797. We don't use commas in C++, by the way, for long values. We just write out the numbers in a straight consecutive line like this. But let's make another variable. Let's say int y equals 914. And now our int result can be 7 plus x plus y. So now that we've declared another variable, ComputerScience needs to add that variable. Oh, right. I remember I have a variable now, y, that I have to remember that has the value of 914. And then this is no longer 3. 8,000 what? 8,797. And result is going to be equal to 7 plus x plus y. And it checks these variables, the values of these variables, once it gets to this line. So now we can output this result, and we get 9,718, which is the sum of these three numbers, 8,797, 914, and 7. I mean, come on. I know you're juiced. You feel that? You feel that right now? Yeah. You are this much closer to being attracted to binary. Okay, awesome. So to recap, we have integers, which are 0, 1, 2, -5, -10,000. They are whole numbers. We have doubles, which are fractions, floating points, or anything with decimals. And then we also have booleans, which are either true or false. And we can combine this logic and start to create actual programs with it. Well, that's all I got. See you later, chieftains.